Yeah, Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important CSIR classical mechanics advanced syllabus question, invariance and Noether's theorem. From Germany, one M.E. Noether is a mathematician family scientist, and in her family, entire the people are mathematicians are there. She introduced the field theory. So that field theory we have to use the here Noether theory in the classical mechanics also. The classical field theory she introduced. So that theory is the Noether's theory. So that theory will give the symmetry, invariance, and Noether's theorem. Already we discussed in the previous classes. So conservation principles we are discussing. Suppose energy conservation principle and the angular momentum conservation principle we are discussing in the previous classes. So the conservation is a symmetry is associated with classical mechanics, right? Symmetry and the conservation of the system is associated. Here you have to see the question in TS set 2017. There was a question based on the Noether's theorem. So based on the Noether's theorem, so what is the question? Once you have to see, choose the wrong statement you have to choose. Choose the wrong statement. Which statement you have to choose? Wrong statement for the Noether's theorem. Choose the wrong statement for the Noether's theorem. The wrong statement you have to choose. That wrong statement itself is a Noether's theorem. What is the option A? First you have to take 4 options are there. Now you observe the 4 statement. The linear momentum is conserved if the Lagrangian is independent of the location of the origin, means that is the coordinate. So what they are giving, the first statement is the linear momentum is conserved. How we have to derive this one? You have to see option A. You have to observe option A. I am observing that linear momentum is conserved. What is the Lagrangian equation of motion? d by dt of dou L by dou Qi dot minus dou L by dou Q is equal to 0. This is the equation of motion of a Lagrangian. What is this? Equation of motion of a Lagrangian. Equation of motion of what? Equation of motion of Lagrangian. The equation of motion of Lagrangian is equal to d by dt of dou L by dou Q dot minus dou L by dou Q is equal to 0. But you know, so what you know, according to your statement A, the linear momentum is conserved if the Lagrangian is independent of the location of the origin. The independent of the location of the origin means the Lagrangian is independent of Q. Location of the origin means independent of the position coordinate. Therefore, dou L by dou Q is equal to 0. If it is dou L by dou Q is equal to 0, that Lagrangian equation of motion will become dou L by dou Q dot is equal to 0. But you know that dou L by dou Q dot is equal to canonical momentum. That momentum is a linear momentum. Dou L by dou Q dot is equal to linear momentum. This momentum is a linear momentum, or this momentum we have to take it as a canonical momentum. This momentum we also call it as a, which momentum it is? Canonical momentum. This momentum is a canonical momentum. So therefore d by dt of p is equal to 0 means p is equal to constant. That linear momentum is a constant means we also call it as conserved. Clear? So the option A is a correct statement you have to see here. So the linear momentum is conserved The linear momentum is conserved if the Lagrangian is independent of the location of the origin. If the Lagrangian is independent of the location of the origin, if the independent of the location of the origin, then the linear momentum is conserved. The similarly, now option is independent of the time. Energy is conserved if the Lagrange is independent of time. This is also correct statement. Which one is conserved? Energy is conserved is if the Lagrangian is independent of time. If the Lagrangian is independent of time, which phenomena is conserved? Energy is conserved. Similarly, you have to take. So the angular momentum is conserved is independent of the angle of measurement means so dou L by dou T. So dou L by dou T. So dou L by dou T is equal to 0 if the Lagrangian is independent of the time. Here dou L by dou theta is equal to dou L by dou theta is equal to 0. If dou L by dou T is equal to 0, dou H by dou T, dou H by dou T is equal to 0. So therefore H is constant or conserved, you have to take. So how we have to write? So option B once you have to see, but we know that. So what we know? So dou L by dou T, dou L by dou T is equal to minus dou H by dou T. But dou L by dou T is equal to 0. It is independent of time. So therefore dou H by dou T, dou H by dou T. If dou H by dou T is equal to 0 means H is a constant. H is a constant. You have to take it as a H is a constant, or H is nothing but what it is. It is a total energy of the system. So H is equal to Hamiltonian kinetic energy plus potential energy, right? So H is conserved means energy is conserved. Energy is conserved. Clear? So similar passion, if you have to take option C. So what is your option C? Your option C is if angle is independent of the Lagrangian, angle measurement is independent of the Lagrangian. Angle measurement is independent of the Lagrangian means you have to write the equation of motion of the Lagrangian dou L by dou theta dot minus dou L by dou theta is equal to 0. Here dou L by dou theta is equal to 0 because your Lagrangian is independent of the measure of the angle. So therefore d by dt of dou L by dou theta dot is equal to 0. If d by dt dou L by dou theta dot is equal to p theta, that is the angle, d by d theta of p theta is equal to 0. So therefore p theta is equal to constant or p theta is conserved. P theta is conserved. So what is p theta? This is a angular momentum. Which one it is? Angular momentum. Angular momentum is conserved. If it is angular momentum is conserved means option C also correct. Now you able to see the options. Option A correct, option B correct, option C also correct. So once you have to take option C, p theta is equal to constant, you are getting that value here. So dou L by dou T, dou L by dou Q is equal to 0. So therefore P is equal to constant, you are getting clear. So like this. Now you have to see the wrong statement we need to calculate. What is the wrong statement you have to observe? The linear momentum, energy and angular momentum are conserved if the Lagrangian depends. If the Lagrangian depends on the location of the origin. This statement is wrong statement. Option D is wrong statement. This theory we call it as a, which theory it is? Noether's theorem. This theorem we call it as a Noether's theorem. According to the Noether's theorem, Noether's theorem will give the symmetry invariance of the systems. Clear? So it is very important option. So please concentrate on this. If you really likes my teaching,
we started the coaching of CSR and GATE physics content. Here DL physics content and JL physics content, you able to get it. If you download my app is Quantum Online Academy app. After downloading my app, so once you have any doubt, you can contact with my number. So my number is 9908437460. So the your courses will get like this CSR and GATE. So these individual papers are so mathematical methods of physics and classical mechanics papers are available now onwards. So these recorded one is finished. This one also finished. All these days we are teaching the electromagnetic theory. This electromagnetic theory is going to live, plus recorded classes are there. If you want to take these 3 papers, you have to take it. So maybe after finishing, maybe one, this is the 48th class. So 2 more classes I have to teach in the YouTube. 50 classes I took, total 50 classes I took in the YouTube. 50 questions, 50 classes means 50 topic questions I took based on the CSR syllabus. So please utilize this chance and estimate my teaching style. If you really likes, you have to take it. It will be useful to you. So please share and subscribe and like. Thank you so much for watching our videos. Thank you.